together. Hello, Robert.
Hi, Klaus.
Yeah. Welcome to our next episode, or our new episode from For Fun with Relux. Our topic today is
irregular or unregular grids. So we're talking about lighting calculation grids. Yeah, what is an irregular grid? How to use it? Why to use it? And everything about irregular grids. Course, we had recently published our sports edition or sports extension of ReluxDesktop. And we found out that there are a couple of grids in sports which are not regular. So we have some strange grids and we need to cover this. And this has a couple of problems to deal with, and also some nerdy explanations where to be aware of by using this stuff. And this is why we had this fun with Relux with this topic today. Yeah. We can show you a bit. Because we have implemented something for this gridding type, which you potentially can see yourself by next week. So we're trying to release our next major release by next week, and this is included. So what you see now is some kind of a preview of what you will also can use by yourself. Also, the grids are for free in the normal version included. But yeah, it's a more or less tricky part to deal with it. And yeah, we have something to show. That's why we should share our screen, that you also can see what we here now seeing on our screens. And we start with a web page from France.
It's a PDF. It's the regulation of France for football stadiums. And here is the first point where we trapped or stepped into this problem, that they are not using a regular grid. They have an unregular grid. You will see that the points in the edges or close to the edges have a different size, not related to the distance between the grid points. So we have here 10 meters between the grid points, but we have 2.5 meter.
Mm-hmm. 2.5.
Yeah. Just sorry, I should wear glasses. And also, it was a little bit our target that we already have implemented this inside of the program up to today. There we have a little bit of delay because in the first step we must implement the functionality that Relux can handle irregular grids or unregular grids.
Yeah.
And we will see later how you can make this. And but here at the moment we have seen that this is in various national standards, especially for sports, maybe also for other standards, are existing such kind of rigs. For example, here this one, or in Switzerland we will have the tennis the measuring grid for tennis places. You will also have here a distance between the grid point of 2.75 meters, but here close to the net you will have 0.9 meters from each side, or 1.8 meter from the side, which also is related to an unregular grid. Also, the grid points are on the borders of the lines.
Mm-hmm. And this grid, also this French grid, looks quite regular, quite even, quite like a normal grid. But the normal grids we have used, or which we are using in normal situations in ReluxDesktop and also in all other lighting calculation applications, is based on one formula, based on Professor Stockmar here out of Germany. And there is a formula with a logarithmic part for calculating the distance between the calculation points. And this formula you can find in all kinds of European and also international standards. So in EN 12464, but also in the sports standard, we have this formula. And this formula is calculating the distance, and with the distance also the amount of grid points. And these grid points are placed with a formula that we have the distance to the edge is the half of the distance between two grid points. We call it a half grid. And this is the basic. This is all in all the standards, and this is important to understand that we have a defined specific grid for all our values we have in the standards. So the standard values are based on this grids. And if you change the grids, then you have different values and cannot really compare this with the standard situation. Even if you have in finer or in wider grids, and also you have directly different values, which you cannot compare so simple. That's why it's important to understand what kind of grid. And for example, if you get in support case where some guys are not happy with the result or complaining that it's not the same as it was in the last version or on the competitor or whatever, then it's one of the first things you need to check is the grid. Just to check if it's the same grid size, is it more dense, is it more wide, is it covering the points where you're calculating or measuring. Grid is really important if it comes to the precision, to the accuracy of the values, and also to the values in total in general. So in this grid looks regular, but the distance to the edges is not the same, and also there's one difference in the distance, and also here in the French version, it's more or less the distance to the edges, which is not regular, and this has an impact in measuring let's say the area below.
Measuring the area, especially the uniformity it's a little bit different. So also, at least before we step into the program, let me show you. This is from the German football, from the German soccer, for the third Bundesliga. So they will use in the Bundesliga or the first two classes a different style, but for the third style there's existing also a irregular grid where you have here, for example, here total different distances between the rows. This is for camera illuminance, and also you have here in the area of the goals, you have also a very smaller distance between the grid points. And the problem is a little bit that up to now, the Relux was not possible to handle such individual styles on grids on measuring surfaces. And before we let's go into the program.
Moment, I have to move it up.
Have to move it up. And before we go to the irregular grids, let's have a small recap to the existing functionality. So if I place a measuring surface and can activate here the grid point so that we can see it. And you will now see, if I change the size of the surface, the amount of measuring points will automatically adjust it according to the formula, which is written in the standard, in this
multiple standards.
In multiple standards.
And this is depending on the size. So the size is the input variant for the calculation of how much is the distance between the points.
It creates the grid points more or less with an equal space into x and epsilon. More, not exactly equal, but more or less. The target is to create small squares.
Squares.
Squares. And also it takes care that each measuring point has the same small patch of surface for evaluating later the average illuminance and so on. And inside of the program, actually, you have the possibility to go here to calculation, and then you can choose some variants from this. For example, you can say you don't want to have this half rusted white distance to the edge. If I switch this off, you will now see that my grid points now are lying on the edges also up to the border, which is not in the most standard, this is not according to the standard, but in some situations you want to have this, or in some situations you need this, or you want this, and then so have the possibility.
For example, this will be the future of the sport standards right now. So in the discussion of the new 1293, we're discussing in the standards committee exactly this, that we want to change PA and TA just to one area, which is having the calculation points on the edges of the surfaces. This is something which can be useful and which is also mathematically fully describable. So it's already in. Yeah.
And another possibility is now, for example, to say you want to adjust the number of measuring points, not automatically according to the formula, according to the common standards. You can say, for example, in my example, something extreme, 5 to 5 points. Then you will have 5 to 5 points all the time, even if you change the size of your measuring surface. So these are
There's one of the benefits for this existing grids is you have 4 parameters and a couple of options, and then you can describe these grids quite easily. And this is one of the challenges with Irregular grid, how to get the user coordinates of this grid points in the most convenient way.
Yeah, this is one of the biggest problems, and here we now come to the extension, which will be available with the next update. You can now click here on this extension button, and you will find here some additional settings. For example, this gradient calculation, this comes in with the sports lighting, and this is important in various situations for sports lighting. It is not related to sports lighting. It is something which just compares the points, your measuring points,
to the neighbors.
To the neighbors, and describes how the point changes. Mm-hmm. But also you will found here a point which is import points, and when you click on there, you will get a small dialog. And from here you can import an Excel file. And in this Excel file, only on the first sheet, in the first 2 columns, you can place X and Y coordinates from your measuring points.
In meters.
In meters. You have also the possibility, for example, to change here. If you take a look to this point, you can type the values as well in here, and then you can modify the points, for example, like this. And this allows you then to bring in the points into on a measuring surface in your own very specific way for things. In our target is later when you are working with sports and you are selecting, for example, when we have implemented the French standard, or for the Swiss, the tennis for Swiss, or whatever, we will include this for you so that you don't have to create this Excel file by yourself. So just select the standard, and then you will get the arrangement of the points in that style.
But there will be the case that you're facing an sports discipline with an irregular grid, which is not already created by us. So you have to create your own, because there's tons of different associations with tons of different nations and national leagues and all kinds of calculations or phases, including all kinds of different irregular grids. So it's not possible to cover it all, but here you have a method to create it by yourself. Of course, a bit of annoying to enter all the coordinates of a sports field, especially if it's large, like football or soccer. That's why, maybe we will also, by creating this, try to use AI or something to check out the coordinates of an image or something. Let's see.
But maybe in the future it may also happen that somebody needs to make a calculation corresponding to any measuring grid. So the most reason why we have this in the sports lighting is because these measuring areas will be measured. So and these are measuring points for real measurements, and then you want to have a calculation which is simulating this measurement, and you will compare this both together. And for that reason, it would be very helpful if you have the possibility to use such a table for the points.
Yeah.
At the moment, we will import these points and put it on the surface. Points which are lying outside of the measuring surface will be cut out. So you must adjust the measuring. No, you must adjust the measuring surface. If I go wider than the points I've imported, nothing more will happen. We will optimize this in one of the next versions, so that you have, for example, a possibility that you import the points and then press a button, for example, or choose an option to adjust the size of the measuring surface adjusting to especially to the grid points.
Yeah.
Yes,
so
and now
so we have problem number one. We have a solution to how to bring in this weird point coordinates. This is the answer is Excel, more or less. And the second bigger issue is that you have to be aware what you have if you're having this kind of irregular grids. Because in our normal situation with a normal grid, you have a representative point for a representative area. So it's possible to say this area had this kind of luminous of illumination, of illuminance, of uniformity or whatever. So the grid points are referring one piece of area below it, because measuring and also calculation is based on points. So we have a point which is calculated. We have also in real on the field measuring, also a point which we measure with a lux meter. But this point is a representative for a piece of a square area. So it's possible to say, okay, I have this kind of this amount of grid points, and this amount of grid points have an average value, and this average value from these grid points are representative for the area. So we can say, okay, this area has a maintained average illuminance of whatever, or uniformity of. This is possible because each grid point has the same area which is representing. If we change this, so if we say, okay, we have some grid points in this corner, some grid points in another corner, or we just messing up with the covering of grid points in the area, then we cannot tell that the area has an average illuminance. So it's not possible because it's not the same representative. We can say the calculated points have an average. This is possible still, but then it's not representative for this area. And it's just the points itself who have an average, but not talking for the area anymore.
We will show this in a short example. I just show you how this Excel file looks. It is just really the first two columns pointing with numbers in values. You can also put 10.5 or something. Yes, you can also use. It's locked. It's not a problem, but you can write any kind of coordinates inside of this Excel file and import the points. Just
in meters.
In meters, yes. So that you have seen it. Okay, but now we will go to the point that
the coverage. What we have now in calculations.
Just a moment.
Klaus has prepared a nice sample to illustrate what I tried to told you, because if you see it, then it's maybe better to understand what I mean. Yeah, because it's not possible to have an average illuminance anymore on the surface, including.
Sorry, I'm a little bit.
You have closed it now.
No, it's here. Okay. Okay.
Just the wrong screen.
Just the wrong screen.
Move it up.
It is so hot here at the moment, so it's a little bit difficult. So what I have made here, we have only a very small, simple, small project. There's only one single luminaire inside of it. It is here in the top of 3 measuring surfaces, A, B, and Z.
It's not even spotty. You can have a sharp spot to illustrate.
Yeah, okay.
But okay.
Yes.
We have some difference.
Yes, we have. We have some difference to what we want to show, and if you take a look to the grid points which we have here the standard grid, which is a regular grid. So each measuring point has the same patch of size, a small surface which taken in account to the average illuminance. And here in the case B, we have the same amount of points, but they are all adjusted to the center of the surface. And here in the case of C, it is a little bit. Need to switch this out, so a little bit outside in the outer range,
a darker area.
So move the points outside. And if we now take a look to the average values here on the right side, you will see in the same situation for the same surface, we have here now an average value which is 5.7 lux, which this is the A. This is this one. 5.7 lux, which is also the average illuminance on this surface, on this 10 to 10 meter to this 100 square meter surface.
Yeah.
So
Here
we have this. This is the average illuminance.
Yeah.
When I click on the B, then we will have 10 lux. This is the average of the measuring points. So just the arithmetic measuring average of these measuring points. It is not the average of this surface, even not on the C variation where we have this. There is only a small variation to the original because it's
Lambert.
I have it's a little bit too wide. I should choose an LDC which is a little bit more narrow to have a little bit more extremer, to see a little bit more extremer the effect of this point. And so this is sometimes then a little bit difficult to check what is the difference now between this. And at the moment, this is in the responsibility of the user to take care of what he is doing at the moment. But we want to choose this, that in the future we will have here, for example, a small note that is realized that this is not a unique distance grid.
Yeah.
And so that there is a difference, that this average illuminance is not the average illuminance on this surface. It's the average illuminance of the grid points on this surface.
Yeah. This is really important to understand, and especially because we leave users option open. So we are not restricting it at the moment. So we have all the options. So it's also typical for Relux that you have a lot of options. You can set a lot. You can also set now the grid points for your own wishes, but you have to be aware what is about the results. The result is not anymore talking for the surface, also not minimum, maximum, and really especially the uniformities. The uniformities are really off if you moving the grid points to something special, or if you're having too much or too less grid points, then it's uniformity, it's something else. It's not representative for this area.
Yeah.
This needs to be keep in mind, but now we have a lot of more options to play around to make your own grids more free as ever. Of course, everything in the background of spots. So this was invented to cover all the special spot grids. But of course, you can do it also in normal situations. So it's not spot related. It's a normal option for all the surfaces where you have calculation grids.
Yeah, it's on.
Yeah, and we had also discussed internally if we should add an area weight to the grid points, which is in extreme cases not possible really. But this is also an option that we have if we have irregular grids, that you can try to calculate the coverage of the grid points on the surface area. This is something that's mathematically possible, that we say, okay, this grid point is covering a lot of space, and this grid point is covering a small space. So the grid point for the much space has a higher weight in the average value. But this is, in the extreme cases, not possible. On this French and Swiss tennis grid, it would be an option to have also area calculations. We do it already if we place the grid points on the edges. Then we do a weight for the grid points on the edges. This is getting just a half of the weight, and the corner points just getting a quarter of their weight for the average calculation. If we're doing like this,
this point is only a quarter. This point will only the half, and this will be calculated the full.
Yeah.
But even this works only easily when we still have a kind of regularity between the points. In the points that we have, it's difficult to. It is not so easy to. It's not if you really make some extreme. If you have here the luminaire and you will put 20 points anywhere here, and then one single point outside here, how you will weight this single point, which
skeleton.
Is anyway
skeleton.
So
some fancy math tools.
From that point, it's not longer serious to use.
Exactly.
Yeah, you must really check, understand what's the difference between what you're having here as result.
Yeah. especially if it comes to standards. So if you're going to calculate an value and criteria against the standard, you have to be sure that that you respect the grid definition of the standard, especially on sports. So in the 1293 and also in the 12464, the most common standards, you have a grid definition, and you need to have this grid in order to apply to the values you have in the standard. So if you, even if you change the grid point amount, so if you stay in the same grid point calculation with a half grid with the formula of Stockmar, if you're having too much points or too less points, even with this grid, you're messing up with the values which are referented in the standards. That's why it's really important to care about the grid. It's also the reason why we print the grid point size in the output, that you can, as a reviewer of the calculation, that you can see, okay, the guy has chosen this grid points to calculate this, and then you can recalculate if the grid points are according to standard or not. If not, then you potentially are not in the scope of the standards. This is important to understand and to respect. And also, again, it's about we're trying to simulate a real on-site measurement. So an on-site measurement is also defined on this grid, and we just doing the same grid as you would do in measurement, maybe just by a quarter of the area if it's regularly, to save a bit of measuring time. But this is the use case which we following here, that we have in simulation of the on-site situation in measurement. And yeah, of course, and there are also irregular grids in reality in measurement for sports, and this we try to follow up, but be careful with the rest of the values, not to be compared with other standards. Yeah, good.
Okay, that was it for the moment. We will see if we have
some questions. Maybe it's a bit of a nerdy topic, but
yeah, it's a little bit
important. It's important.
It's important. So we have no questions at the moment. So
it's also something, if people are complaining in our support that the values are not according to other standard, not to other versions of our application or to competitor applications. So if there is a mismatch of values, one thing which we check early is, beside the maintenance factor, of course, it's also the grid. So if you messed up the grid, also the height of the grid, not just the size in 2 dimensions, also where is the grid. This is really important to compare values on the first point. Then, of course, there's more which you can do to check out what is the reason for indifference. Oh, we got one question.
No, that's a test.
Just a question. Okay.
Just one of our colleagues tested if the functionality still works, just to be safe. So we think you have no last chance. If there are no questions according to this point, and the only thing we have to do is to take a look to the next episode.
Yeah. One special thing is the episode for July is skipped. So we do not a July episode. So you have to wait till August. So we do a summer break with Fun with Relux, as we have did last year also, and small summer break of 1 episode. So the next episode is in August, in late August, on the 27th of August is our next episode. And the topic is AutoCAD and FBX. So we're going a bit into the AutoCAD plugin, so what you can do with AutoCAD, maybe in both directions. So the in and export of AutoCAD, also maybe our plugin in AutoCAD, and also FBX as let's say an interfacing of 3D objects between AutoCAD and ReluxDesktop. There was already an episode of both topics, but not in a whole, and it's a long time ago. That's why we doing a follow-up on this. Okay, then see you in August.
Thank you.
Have a nice summer.
Have a nice summer, and see you next time.
Bye. Bye.